Hello, everyone, and welcome to another edition of our Akka.net community stand-ups. This is for March 2024. Gregorius, how are you doing today?
Oh, pretty good. How are you?
Good, good. So you've been working on a bunch of Akka.Analyzer rules, right? What you've been up to
Mm-hmm.
the past couple of days?
Yep.
Um, I have been furiously working on some Phobos fixes and also getting ready to start work on one of the big projects we're going to talk about at the end here. But before we dive into that, why don't we talk a little bit about some of our recent releases we've been working on? So, Gorius, why don't you take us through real quick? We did Akka.net 1.517 and 1.517.1, which was basically kind of
Mm-hmm.
a boo boo, so to speak. Um,
Yes.
why don't we go into some detail on that real fast? So, take us through 1.517.
For 1.5.7,
Yeah,
um,
1.517. Sorry about that. That one.
yeah, 17.
So,
Um, Hold on. I haven't pulled it out just yet. Oh, okay. So there was a contributor contribution for fixing up log source, it has been around since the beginning, I think.
I think I've gotten like 30 bug reports for that null reference exception, and this user fixed it. So thank
Yep.
you. Thank you, kind open source user, for making my life a little easier. So yes, that was super annoying. And you fixed another annoying logging problem, if I recall correctly.
Uh,
That'd
which
be the
one's
timer
that?
scheduler stuff.
Oh, yes. This is also a bit of a neck point for me. Every time I use the iWith timer interface, it would log everything. And if you have like 10 actors using it, the log would just be filled with timer start, timer stop, timer start, timer stop. It's annoying.
Yeah, if you tried running
So
him. Sorry, go ahead, Gregorius.
yeah, so we added a new config that allows you to just suppress all that messages.
And it's enabled by default now, right?
Mm-hmm. Yep.
Yeah, so we made it so you have to opt back into the noisy timer scheduler feedback rather than opting out of it. Yeah, if you were running with, like, let's say, sharded entity actors using iTimer scheduler and you had like 500,000 of them and you're running with debug log settings turned on, good luck to your logging server for being able to keep up with that. Um,
Mm-hmm.
but yeah, so I'm glad that's off. You also implemented this Akka delivery bypass feature, which I thought was useful. Pull that up real quick.
Mm-hmm.
So this was, if you're using Akka delivery, which we covered, and I guess we'll link to the video here after this gets recording goes live. We added Akka delivery like May, June of last year. It's a reliable delivery system for Akka.net, and it has a flavor specifically for cluster sharding. One of the things that was kind of awkward is if you opt into using that feature, everything had to be delivered through Akka delivery. We added a bypass feature that's not enabled by default, but basically allows you to kind of like sidestep around it. So you can just message the entity actor directly without needing to use all the Akka delivery sort of ceremony. So
Mm-hmm.
yeah.
And it's really useful if you want to use like a custom handle stop message.
Yeah, that
Uh,
was sorry, go ahead.
yeah, one caveat is that you still need to set the message using a envelope because the delivery system still doesn't know where to send it unless it is wrapped inside the sharding envelope.
Got it. Yeah. Well, actually, I think that's only true on the sender side. I actually don't think you need an envelope because if it's made it all the way to the sharding consumer controller, then it's already gone through the sharding route system. It's just like one little local hop that needs to happen afterwards. So I don't think that's actually true. I think that basically that's true on the producer side, but not on the consumer.
Yes.
Um, and on the producer side, I mean that if you're trying to send that message through the Akka delivery system, it's matters. But if you're just a normal sender, you just need to send something that your message extractor will handle, which is the same as it always was for sharding.
Yes.
Um, Next big thing I wanted to talk about was Akka.Analyzers 2.31, which
Mm-hmm.
was, boy, this was a big MS build adventure, all this stuff here, which
Yes, it
was
is.
Yeah, basically we had to try to figure out so you added some improvements to some of these Akka.Analyzer rules. We got rid of the let me open this one up. We got rid of the rule that flagged closures for pipe 2 because the user pointed out that we actually fixed that feature in like Akka.net 1.430 something. So we're like, oh yeah, cool. Guess we don't need it anymore. So that rule no longer exists. Got rid of that.
Mhm.
And then this was the big thing we added was multi-targeting support for older versions of Roslyn. Now, who uses older versions of Roslyn? That would be older users of users of older versions of Visual Studio, right? So
Mhm.
Roslyn basically the version of Roslyn basically maps to the version of Visual Studio you're using. So the new version of Roslyn that's out there right now is 4.8. Um, but
Well, the preview is actually 4.9.
4.9 is the preview now. Okay, so if you're
Yeah.
whatever the new version of Visual Studio will be after 2022, I guess that'll be what VS 2024, 2025. That'll be 4.9 and higher. So we have multi-targeting now. So if you're using Visual Studio going all the way back to I don't know, to Visual Studio 2017 should work with this. So you should be able to get Akka.Analyzer support going all the way back now. That a little bit of a learning curve for us on figuring out how to do it. We kind of just reverse engineered what XUnit does for their stuff for their analyzer rule sets and just brought it over to ours. So that's all working. And then we have the primary thing we were going to discuss today, which is Akka.net 1.518, which is there's just a single commit in here. And a little bit of backstory here. The biggest thing that we did is the only thing we did in this release is we migrated all of our dispatchers off of the dedicated thread pool. So a little bit of history for longtime Akka.net users. We've had a dedicated thread pool in place really since Akka.Remote came out of beta, which would have been in early 2014 sometime. And the reason for this was to perform basically workload segregation. Um, your normal .NET thread pool is where every single piece of asynchronous work in the .NET ecosystem gets scheduled, with the exception of tasks that were marked as long running. If you use those task creation options enum, a long running task you get its own thread. But aside from that, everyone else got scheduled in the .NET thread pool. Where that is problematic, or at least historically where it was problematic, is that in the event that you had some workloads that were more time sensitive than others, this could mean basically experiencing a little bit of thread pool starvation to some degree, where those real time sensitive tasks were given the same priority as everything else. Therefore, they could not basically get their workload done on time, and you'd have basically a bunch of false positive sort of failures inside your system as a result. Um, so the way we mitigated that for Akka.Remote was we moved it onto its own dedicated thread pool that used some very primitive thread scaling and work queuing systems, and basically it had a separate queue of work independent from the .NET thread pool. So we kind of moved the scheduling contention from being in the .NET thread pool to the operating system's scheduler. And that resulted in basically applications being generally more stable, more performant, and it basically performed a lot better overall. But a problem that that dedicated thread pool has always had is that it's not nearly as resource efficient as the normal .NET thread pool is at being able to wait for work, being able to do work sharing, and also the dedicated thread pool doesn't perform hill climbing, which is what the .NET thread pool does. Hill climbing is basically a type of algorithm for trying to find basically local maxima inside a curve. The basic way to think about that is the amount of work your application has can scale up and down dynamically, based off the number of clients connecting to your website or the amount of data you're ingesting. And the hill climbing algorithm will try to dynamically adjust the number of threads in order to maximize throughput, or really minimizing latency is kind of what they're going for. So trying to make sure work items get processed as quickly as possible. There are a lot of cases where reducing the number of threads can actually improve that latency by reducing things like context switching. There's other cases where scaling up the number of threads can help improve by just having raw parallelism there. So that's kind of what the hill climbing stuff does. The dedicated thread pool did none of that, and it had relatively inefficient ways of waiting for work. As a result, people would go ahead and report, like this issue from 2021 here, would go ahead and report relatively high idle CPU, relatively high CPU load for idle clusters. And I've been able to reproduce this myself, where I would spin up like a 400 node or a 200 node Akka.NET cluster on Kubernetes. And using the normal dedicated thread pool, you'd see 80% CPU utilization when there was no traffic on the system. Now, that being said, as soon as that system came under high load, you would still see, basically CPU numbers that were basically in that same ballpark, but they wouldn't move very much. Because the issue there was that the CPU numbers were artificially high because of inefficient waiting for work. That's really kind of the problem the dedicated thread pool stuff had. So we were kind of faced with a decision here on, okay, in .NET 6, they significantly improved a key design flaw in the .NET thread pools, like original implementations, which is that they added a technique called thread injection, which is that when it detects that items in the thread pool are waiting synchronously, so let's say they're calling task.results or they're doing some other type of blocking operation, the .NET thread pool's hill climbing algorithm can actually detect that and start injecting more threads until those sources of blockage get cleared. So they made the thread pools much more resilient in .NET 6 than they used to be, which is something that we figured would be able to help support Akka.remote quite a bit in terms of making sure its workloads get through. On top of that, the thread pools are much more efficient now. They don't use low-level C++ code anymore. It's all basically all C# code now that manages the thread pools in .NET 6 and later. And as a result of that, they can benefit from things like dynamic profile guided optimization. And generally speaking, we've seen that the performance. Scroll down and show some performance numbers in a bit, but the performance of Akka.NET is generally both higher from a total throughput perspective, and the idle CPU is much lower. So to give you an example here, I went ahead and I fired up a local instance of my large Akka.NET network test. Now we're only running like a 6-node cluster here. But if I take a look at the CPU utilization, and we're generating kind of a constant amount of traffic inside the system, yeah, we're basically operating, let's see, where are my pods here? This is one of them. So this pod is operating at like, let's say 12% CPU, and this is doing a whole bunch of distributed pub sub, cluster sharding, Akka persistence, Akka remote. It's also doing a whole bunch of Phobos and open telemetry stuff. And so it's doing, I think, I don't know, basically maybe a few hundred messages a second, that node. And that's all going over Akka.remote. And you got some other ones going on here as well. Most of the CPU utilization in this cluster, if I scroll through here, yeah, I see these various pods are bumping up and down here. This is going to be radically lower than what we would have had before with a dedicated thread pool. And it's because the .NET thread pool is now in charge of everything. We do not have any dedicated thread pools running anymore. And if you take a look at the CPU numbers in terms of, the throughput numbers down here, this is our remote ping pong benchmark, which measures Akka.remote performance. So Akka.remote's one of the areas that'll be more impacted by this change. And let's say local actors. Local actors were already using the .NET thread pool, so there's no real difference there. But the system actors and the remoting actors were all using their own dedicated threads. Well, you'll see here that we're doing at peak performance about 719,000 messages per second. And our probably median performance is like 667,000, somewhere in there. Down here, the performance numbers are very consistent for Akka.remote. They're not quite as spiky as they are here. And one of the reasons for that is you'll notice the total thread counts are significantly lower in the new basically Akka.NET 1.518. So at peak, we're running with, let's say, 120 threads, 123. We were running with 173 at peak here. And then in terms of our minimum thread count, we start off with 73 versus 129. So long story short, the new Akka.NET's using much lower thread counts than it was before. Its CPU utilization is a lot lower. If you go and profile Akka.NET, you won't see the dedicated thread pool, like weak semaphore slim or whatever the hell that synchronization mechanism is called. You won't see that show up on the profiler anymore because it'll all be system calls now where all of the waiting happens. So we think that this should result in, generally speaking, The performance you should get in terms of Akka.remote and local Akka's messaging will be about the same. Like if I scroll down to local ping pong, I think I wrote up a note down here. I think our maximum performance on this computer, let's see, this is our baseline. So yeah, about 135 million messages a second inside the system. And then if I go up here, it's about the same, 135 million messages a second. So no real impact for local actor messaging, and for remote actor messaging, we have slightly higher peak performance, which is pretty cool. And we're doing it with many fewer threads than we used to. So this should all significantly improve the overall, let's say, resource consumption profile of Akka.net. We still have even more work that we're going to try to do in the grand scheme of things, because one of the other big sources of thread utilization in Akka.net is actually .NETty, our transport layer. We are planning on replacing that in Akka.net 1.6. We're going to use Microsoft's MS Quick implementation, which will basically move this back onto things like IO completion events, and it'll use the .NET thread pool just like everything else does under the covers. So we should see these numbers, the thread count numbers, go down even more in 1.6, and we'll see the performance numbers go up even more. Now, we're not planning on starting serious engineering work on 1.6 for a little while yet, so we're probably not going to begin work on that until Q3 of this year, but that is part of the plan for now. We're mostly kind of doing a bunch of R&D and a couple other projects, which leads me into our next section here. We'll go ahead and put up a little banner. Upcoming Akka.net releases. So what do we have cooking? One of the things, and I haven't filed an issue for this yet because I haven't had a time to write a specification, but one of the things that we're going to add is an Akka.net logging filter. This is going to allow you to basically disable certain sources of log events at various logging levels if you want. So a good example, this user submitted an issue here. If I scroll up, they are trying to start up millions of Akka.cluster sharded entities all at the same time. And the debug logs they get when they turn on debug logging are just, it's overwhelming, probably because of issues like that timer scheduler one you fixed, Gregorius.
Mhm.
So there's just too much stuff to sift through. So what we're going to try to do is add basically like a little predicate system that you can use to say, you know what, if for debug log levels, we only want logs from these sources using like a little wildcard filter. So you could say /sharding on there, and that might go ahead and only include debug logs in the sharding system. That way, debug logs from things like individual actors or Akka persistence or Akka.remote, none of that will show up in the output there. So this should give users much more fine-grained control over the whole output system. So that's something that we're going to try to implement in relatively short order here. I should have a spec written for that next week, hopefully. So keep an eye out for that on the Akka.net GitHub repo. Now, the next big thing we're talking about, and we brought this up last summer after we did our last round of our Akka.net developer survey, which typically we do once a year. So we're going to do our developer survey again, probably next month. We usually do it in April. But the number one piece of feedback we've gotten for several years in a row for Akka.net is basically that the learning curve is too high. The documentation and samples are old, especially Akka.net Bootcamp. That one got mentioned by name a few times. And then on top of that, a lot of the documentation reads like Swinglish, like it was ported from the what's it called? Ported from the original Scala Akka website, and was never really kind of rewritten in like a simplified, easily approachable way. That sort of stuff. Those are all the bits of feedback we've gotten from users when we've done surveys. And I mentioned at the time that, hey, we hear you. We're planning on addressing this in the future. Well, I'm pleased to announce that we are starting work on that basically this month. I am basically going to embark on rewriting Akka.net Bootcamp and all the Akka.net documentation from scratch, essentially. We might keep some stuff that's in there, but I'm convinced that basically we need to, do things like work Akka hosting directly into all the starter samples and everything else. We probably need to work the .NET new templates into all of our tutorials and examples as well. And then to boot, we just need to go ahead and simplify things, and also try to provide more code snippets to help make things a little bit more approachable. Like a good example, go to the Akka.net website here. One thing I really want to do, if I go to the streams area, is this is like the overview of all the different built-in stages in Akka Streams. We kind of describe what these components do, but we don't show you. So we're telling but not showing. What we're going to do here is try to have a little embeddable sample of every single one of these built-in stages so you can observe how they work. We're going to try to use a try.net for this, which is basically a way of kind of embedding hosted samples directly into your website and being able to go ahead and run them with a .NET interpreter connected to it behind the scenes. Um, Technically, it looks like it should be feasible. We haven't quite dotted all of our I's and crossed our T's on that yet. So we might, if we run into problems there, we'll reset expectations for the community accordingly. But that's something that we're going to try to do. And we hope to be done with this project in the next few months. So all of the feedback about the Akka.net learning curve, we've taken all that real seriously. My sort of interpretation of all that here is that Akka.net is actually on the in the grand scheme of things, Akka.NET is actually fairly straightforward to learn from a syntax and from a what do the tools do standpoint. But what we don't do is we don't clearly illustrate a path to users for how can you gradually incorporate Akka.NET into your solution? How can you start being productive with it without going and building a full-blown Akka.NET cluster from scratch and building like a greenfield application? How can you begin gradually using it, learning how it works, and grow into that? That's not really a pathway we've described in basically accurate detail. And I also think that some of our learning materials are showing their age a bit. Like, good example, Akadana Bootcamp still, talks about using WPF and Windows Forms, with both two technologies that, while they're still around, kind of aren't exactly used for much other than legacy systems these days. So I think that we are going to go through and basically practice a little bit of creative destruction. Burn down what was there and replace it with something new. Take all the lessons we learned from it, make it available there. Try to make the documentation more approachable, more searchable, and more interactive, so it should be more runnable. And generally speaking, try to make sure that questions about how do I deploy into these environments, what are some users who have a use case similar to mine. We've had these show and tell presentations we've done on these live streams here from customers in a bunch of different industries, where they've all talked about how they get value out of Akka.net. We're going to go ahead and make that more accessible on the website as well. So if you are interested in learning about IoT, maybe you'll see Priva's example. Or if you're interested in learning about using Akka Streams for being able to do real-time analytics, maybe you'll see Echo's video out there. All sorts of different little examples that we can bring in to kind of help make Akka.net more saleable for people. And yes, this bit of feedback here, cloud hosting examples would be grand. So Gregorius, your samples on how to deploy Akka.net to application Azure App Services and Azure,
Hmm.
is it not cloud apps, container apps? Is that the other one? Those are all things that would
Yes.
get featured pretty upfront and visibly inside our documentation going forward. So we're very keen and intent on doing this because we recognize that this helps make it easier to kind of teach other people on your team how to work with Akka.net, helps management understand how to leverage Akka.net for use cases, and also just generally speaking, it makes it easier for everybody to learn and find solutions to their problems. So that is going to be a big project that we're going to go ahead and start on. I basically presented it to my team at our OKR meeting on Monday. This is the next big thing we're doing. So we're going to be working on that, and we hope to have this done. Obviously things might slip if other priorities come up, but we're going to try to have this done by Memorial Day. So basically end of May of this year. So that'll do it for, I think, our March community stand up. Unless Gregorius, you've got anything you want to add?
No, I think you covered it all.
All right, cool. Hey, we are looking for show and tell speakers. So if you're a current Akka.net production user and you want to go ahead and talk a bit about your usage of it, it always helps the community to get more examples of how they can be productive and successful with Akka.net. Please go ahead and let us know. You can always reach out to me on Discord, or you can click on the link on our GitHub discussion about Akka.net community stand-ups. And there's a little Google form you can fill out there. Maybe we'll go ahead and distribute that in the Discord right after this call. But otherwise, thank you very much, everybody, for your time and attention as always. We appreciate you and the community, And we will catch you again in April with an update on all this stuff that we're working on. So thank you very much. And until next time, see you later.